Uh, Hello my dear friends, welcome to all of you to YourPedia and Engineers Career Point. So my dear friends, today you are going to be discuss the Airport Authority India their question paper after 2016 to all the question paper that was asked till now. Okay, that means last exam was conducted in 2023. So till date, whatever question has been asked from the physics part, especially today I am going to deal about the 11th class physics. Whatever question has been asked from the 11th class physics, that today I am going to deal here. And you have to be keep patience because various number of questions and the number of sheet was there, so question is high. That's why it will be that video will be the little bit lengthy. So you have to be keep the patience. And one more thing my dear friends, generally what's happen, student think ki okay, physics are difficult and it is a tedious, that is difficult to solve in the exam. But my dear friends, once you go through the that analysis, you could be able to find that really question paper going to be asked here is a very easy. If you have proper guide and you have visited your syllabus properly, then I don't think you will find difficulties. One another question that I mostly I'm going to ask by the student, sir, should I start the study of physics of the 11th IIT JE and 12th, which is according to the IIT JE? No my dear friends, that is not required there. If you go through the question, we can say very simple question, but the thing is that you have to be just little bit idea about your basics. If you have basics, you could be very able to solve the question. Very basics question are going to be asked, and at the end of analysis you can be able to you can do analysis on yourself. Okay, so how much question, how much and what is the depth of the exam. That's why actually a student is mostly going to be fear by that exam, okay, question how going to be asked like that. That's why my dear friends, we have started, YourPedia has started the different a specific module for Airport Authority of India that you can join, where you are going to be deliver the content according to requirement of your exam, according to requirement of the depth of your exam, what is needed, which thing is not needed. All the things I am going to be discussed in the class that was started from the 10th of April. Okay, and yeah, one more question I am going to be mostly going to be asked by the student, sir, what is the tentative date of that exam? What is the tentative date of that exam? That is another question very frequently going to be asked. My dear friends, I think it should be approximate, we can understand 15th of around 15th of June, little bit it can be more or less than that, but approximate. So you have 2.5 or approximate 3 months you have, and I think that time is sufficient if you are preparing. Not that time is sufficient because if you see the level of question, you will, some question are calculative, no doubt, some question are calculative, but rest question are very easy. Some question obviously are calculative, it will take some time, but not all questions, only few questions are calculative. Okay, so my dear friends, let's start the session without delaying a further second. That is the first question. We can say ball A, here we can say ball A 3 kg moving with a velocity of v naught I makes a head on elastic collision. Okay, here on see elastic collision. What? Elastic collision with another ball B initially at rest. After collision, ball A continue to move with a velocity of v naught upon 5I. The mass of ball B is, here I is unit vector along x direction. So my dear friends, that question has been taken from the one chapter is there, collision. So that question has been taken from the collision, my dear friends. In the here you can say the collision is various types of collision: perfectly inelastic collision, elastic collision, perfectly elastic collision, inelastic collision. Various types of collision is there, right? So in the question is that, my dear friends, this is the elastic collision. So how what you have to be calculate? Mass of the ball B. Yeah, I can say little bit calculative question, but concept is very easy behind that question. So what you have to do, my dear friends, since the elastic collision, no sir, like that, suppose this is the ball A having mass 3 kg, it is moving with a velocity of v naught, and let's assume this is your block B, which is initially at rest, makes head elastic collision with another ball initially at rest. Here velocity is 0 initially. After collision, once they are going to be collide, ball A continue to move with the velocity of, after that the final velocity of that one is v naught upon 5. So the mass of the ball B they are going to be asked. My dear friends, we can say here how can solve the equation. My dear friends, you have to use the two equation. One is called conservation of momentum, one is called conservation of kinetic energy. So what is the conservation of momentum, my dear friends? You simply we can say, sir, MA VAI plus MB VBI initial velocity equal to should be MA VA final velocity plus of MB VB their final velocity. That is the one of the equation that you have to be used, that is known as momentum equation, conservation of momentum, because elastic collision is there, right? Now what is second? That is the first that you have to be used. What is the second? Because here two unknown are, my dear friends, two unknown. One, mass is also unknown, and V final velocity of the block B is also unknown. So two unknown is there, right? So you have to use the two equation. Another you can use the conservation of kinetic energy. Conservation of kinetic energy simply you can use half mv square. So ma vai square plus half mb vbi, I means initial velocity square, equal to what, my dear friends? Half ma vfa square final velocity plus of half mb bf whole square. These two equations we have to be solved. By solving these two equations we will get the answer. I am going to just put the value, my dear friends, here. So from the first equation what we can say, ma, how much ma is given? Yes, in all that question analysis, that question is calculative. Rest question are not calculative, you can just keep a patience, okay? So here we can see mass of A is given. How much mass? This is given 3 kg. Okay, sir, that mass is given how much? Okay, not known, sir, not known, that is not known. Okay, so my dear friends, here you can say by using that equation what will be ma, so 3. What is va? So you can say, sir, this is given v naught I plus, okay, mb, initially body is in the rest condition, so it will be 0, equal to half m v2. What is v final velocity? V naught upon 5. We can say, sir, v naught upon 5 whole square plus half mb vb f square. From that you can get one equation now. Simply we can get or not get, my dear friends? We can say, sir, from there we'll get the one equation. We can say here from that one you are getting by using that equation you are getting the relation. I am just going to write mb vbf, this is coming out to be 12 v naught upon 5. Okay, that is by equation. Now two unknown is there, so need two equations. So that is the first equation. How we can get second equation? From that one, na? Half ma is how much? 3 into v naught square equal to initial this one is 0, so leave that, equal to half m, so 3 into v naught upon 5 whole square. Okay, v naught upon 5 whole square plus half. Okay, just 1 second here, what you can check out it in the momentum conservation. That one is momentum conservation. Here half will not be there, na, just only mass, so here not half is there, so here will be half, just remove that one, simply. Okay, plus half mb vbf square. By solving that, my dear friends, I am going to give you the equation that I have came with. We will get mb vb square f is coming out to be 722 v naught square upon 25. That is equation second. And by solving equation and first and second, we will get mass of block B is coming out to be 2 kg. Just solve that equation. Yeah, little bit that question was calculative, but not all the question is calculative, you can see here. Okay, but what was the major things, my dear friends? The major concern of that question is that what you have to be learned, that in the collision, here elastic collision, you have to just keep in mind one equation you have to use the momentum conservation, another you have to use the kinetic energy conservation, and by that way you will get the answer. So it was an easy question, yeah, slightly calculative, no problem, you can do that. Come to the next question, my dear friends. That is the next question. A particle moving at a constant speed pi meter per second on a circular path. Which path? Circular path. Radius is given 1 meter. It will complete one revolution. In how much time it will complete one revolution, that is given. So we can say, sir, I know how much time it will take to complete. See, a particle moving with a constant speed. This is a particle. Let's assume one particle is there. This particle, it is moving with a velocity of how much? Pi meter per second. Pi meter, their velocity is pi meter per second. You know, velocity is given by how much, my dear friends? Simply we can say, sir, pi dn upon 60. Right, from that we can get the velocity. So it will complete in one revolution. See, this is the velocity. In one revolution, how much distance they have to be covered, my dear friends? In one revolution, how much distance? So we can say their circumference, sir. In one revolution, how much distance they will cover? So one circumference, right? Circumference na. So what is circumference? That is pi into d, na, sir. And what is the velocity? V. So how long time it will complete in one revolution? In how long time? So simply we can say that much distance is to be covered with the velocity that one. So what will be time? So obviously we can say, sir, distance upon time. So distance is pi d upon what velocity is what pi. So it will be cancel out, coming out to be d. In the radius, question is given, what is the radius is given. So we can say d equal to 2r. And 2:1 is coming out to be 2. So see how easy question it was. Simple question was, not calculation, just basics is going to be checked here. Okay, circumference is what? Pi d distance they have to be covered. Their velocity is a pi meter per second. So how long time it will take to complete one revolution? Easily you can be able to do that, huh? So basics question was there, but yes, you have to be going through that topic. Once you go through the topic, I don't think you will find any difficulties in that type of questions. Okay, my dear friends, so coming to the next question. That is the next question. See, an electromagnetic wave travel from one medium to another medium. Which of the following quantity changes? Which of the following quantity changes? Electromagnetic wave, sun rays itself a EM wave, electromagnetic wave. So when they are coming, going to the one medium to the another medium, may travel from one medium to another. So what is happening when they travel one medium to another medium? Their wavelength changes. If wavelength changes, obviously frequency will change. If frequency will change, obviously speed will change, my dear friends. So that is the question of the electromagnetic wave that will be taught to you in the 11th class physics. Even I will teach you, so don't worry. So my dear friends, in this case, bol raha which quantity will be going to be changed out. So all the quantities are wavelength, frequency. If you talk about wavelength, frequency and speed, so we can say, sir, these all frequencies also there now. Frequency, wavelength. So correct answer is what? D. You can make them one correct. Correct answer is what, my dear friends? D. So try to be remember that one. See the next question. What is in an elastic collision of two objects? Consider the following physical quantity. See here, elastic or inelastic collision. So here we can say, sir, this is not elastic, this is inelastic. What do you mean by inelastic collision? In inelastic collision, the loss can take place, right? Whenever the collision is there, the losses can take place. Not the all the energy going. Elastic collision is what, my dear friends? Let's see. Suppose these two are body, they are going to be collide. Okay, so whatever momentum they have, they are going to be transferred. No any loss is going to be takes place. That is called elastic collision. In elastic collision, what is happening? In elastic collision, that is elastic, no loss is there, called elastic collision. Elastic substitution E is coming out to be 1 for elastic collision. If you talk about inelastic collision, so what is happening? Okay, they will come, they have energy momentum, but whatever momentum they have, all are not going to be transferred to that one. Why? Because some part of the energy is going to be here lost during the collision. So that is called inelastic collision. Coefficient of restitution in elastic collision always less than 1, my dear friends. So here in the question it is given inelastic collision, sir. So what is the correct answer? What is the? So my dear friends, so total linear momentum. Yes, my dear friends, it will be constant. First, total linear momentum is constant because no external force is there. That's why total momentum is constant, no problem. But if you talk about total kinetic energy, sir, since the here loss is takes place, na sir. So if loss is takes place, kinetic energy is not remained conserved, sir. It can be only, it could be only if there should not be any loss. But since loss is takes place, sir, that's why it can't be, sir. So what can be correct answer? One is conserve, but second is not. So correct answer is what? Chennai. In the first question that we have discussed, we have seen it was an elastic collision. That's why I have used the conservation of momentum as well as conservation of kinetic energy. But here, since it is in elastic collision, so energy is energy loss takes place. That's why the kinetic energy, total kinetic energy will not remain conserved. So we can say the only Chennai is the right answer. What is the next question? That is another good question, but basic question was, my dear friend, that was the basic question. What is the question? Question is that a block of mass m is placed on a rough wooden horizontal plane. The inclination of the plane is slowly increases. When the plane makes an angle 30 degree, the block just starts sliding down with a uniform speed. The maximum coefficient of static friction between the block and the plane is. So my dear friends, simple question was there. This was here. Initially you are going to increase, and that was, let's assume that angle is 30 degree, and here one mass you are going to be placed. Let's assume the mass m is there, right? Okay, uniform speed, the maximum velocity, the maximum coefficient of static friction between the block and the plane. So my dear friends, you know, from the APD we can say mg is going to be act here. So this is theta, so it will be 90. It will be 90 minus theta. And you know, reaction always act perpendicular to the surface, so that is, you can say r, that angle will be theta. So here will be mg sin theta, mg sin theta, or here this way will be mg cos theta, right? Mg cos theta. So my dear friends, and in this way what is happening? Frictional force. So we can say, sir, when they will move, so we can say the frictional force is equal to what? Mu into n. What is the value of frictional force? Mu into n. What is the n, my dear friends? So we can say, sir, n is equal to mg cos theta. So it is moving with the uniform velocity, my dear friends, uniform speed. When they can move the uniform speed, when both will be the equal, no any unbalanced force is there. So simply we can say, sir, mg sin theta should be equal to what? Frictional force is equal to mu mg cos theta, right? So you have to be calculate the coefficient static friction mu na. So mg will get cancelled out. Okay, so mu will coming out to be, sir, sin theta upon tan theta, right? Sin theta upon cos theta. So it is coming out to be even tan theta, we can say, or you know, just put the sin 30 is what? Sin 30 is half, cos 30 is root 3 by 2. It will be coming out to be cancel out 1 upon root 3. So what's the value you are going to be get, my dear friends? 1 upon root 3 is the answer. Okay, so that question has been taken from the friction. So from that, even all the you know paper, all the section, all the you know parts, everywhere, if the 11th question is from the question has been asked from the 11th physics, then yes, one question is from the friction. So the conclusion is that, my dear friends, friction is important. You cannot leave the question of the friction. It is important. One question every year is going to be asked in your exam. Okay, and like that question, simply you are able to do. Sometimes angle of repose is what, angle of friction is what, like that question has been also asked. So I will deal that question is also. Coming to the next question. What is this question? A particle executing simple harmonic motion. Is it visible to you guys, na? With time period t, its kinetic energy changes periodically with time period of. That is the another question, my dear friends. So simply we can say, okay, a particle simple harmonic motion with time period t, its kinetic energy also changes periodically with time period of what? It is coming out to be, my dear friend, just try to remember, t upon 2. That is the next question. Okay, do one thing, I am going to prove that one. Otherwise, you know, my dear friends, you have to be just remember that relation. Otherwise, you can prove that one also, but you have to be just remember that equation. But let me going to prove that one. Okay, otherwise obviously you find difficulties. Sir, how this is coming out to be? So let us, I am going to be prove that. So don't worry, it will take hardly 1 to 2 minutes. So the question is that time period in simple harmonic motion, if you talk about, so simply we can say, sir, time period, if you talk about T, kinetic energy in SHM simple harmonic motion, kinetic energy is given by kinetic energy in simple harmonic motion, kinetic energy given by obviously half mv square we can say, but the some concept that you have to be just keep in mind here, we can say kinetic energy in harmonic motion it is given by half mv square. For SHM simple harmonic motion, x is equal to, if anyone have remember, a cos of omega t, a cos of omega t, a cos of omega t. Okay, if you have to get the velocity, we can say, sir, dx upon dt. Now dx upon dt, so what is it is coming out to be minus a omega sin omega t. Okay, so what is kinetic energy? We can say, sir, half mv square, so half m instant of v minus a omega sin omega t whole square. So from there we can say, sir, kinetic energy is coming out to be half m a square omega square sin square omega t, and you know sin square theta is equal to what, my dear friends? If anybody have little bit trigonometry, we can say sin square theta is, I know, half of 1 minus cos of 2 theta. That is from the trigonometry, right? So after that what we can say, just put that value. So kinetic energy is coming out to be, my dear friends, we can say half m a square omega square half of 1 minus cos 2 omega t, and from that we can say this is coming out to be kinetic energy from that 1 upon 4, right, m a square omega square 1 minus cos of 2 omega t. And you know, my dear friends, what is the period of cos theta? Period, you know, by which it is going to repeat its value. So periodicity of this is simply we can say the function cos 2 omega t has period of how much, anybody? That is from the mathematics you might have remember 2 pi upon 2 omega, or we can say pi upon omega. So omega is equal to what, my dear friends? Simply we can say, sir, 2 pi by 30. So what will be time period, my dear friends? What will be time period? So we can say, sir, pi upon 2 pi upon t. Pi will cancel out, it is coming out to be t by 2. Now it is coming out to be what, my dear friends? So from there we have seen this is what, cos omega 2 omega t, so it is time period. So from that we can say, I know, sir, period 2 pi, so cos 2 omega 2 has period is what, 2 pi upon 2 omega, you can say, or simply pi upon omega. So underneath omega is what, 2 pi upon t. So just put the value here, that value, and after that it is going to be cancel out, and that value is coming out to be what, my dear friends? It is coming out to be t by 2. So that's why it's better, you cannot do all that calculation in the exam. So try to be remember what conclusion, main thing in the simple harmonic motion you have to be keep in mind the displacement is given by a cos omega t. Okay, and after that you can get the velocity. That just a point that you have to be just keep in mind. Next question, identify the option that arrange the following in chronological order of Carnot cycle. So what is Carnot cycle, my dear friends? That is the question has been taken from the thermodynamics that I will deal with you. Thermodynamics question this is. Okay.
Bye.
Na? Clear? So order of Carnot cycle they are going to be asked. Isothermal expansion, okay, after that isothermal compression, adiabatic expansion, or adiabatic compression. So my dear friends, first arrange the, so first of all what will come, it will come isothermal expansion. After that you talk about adiabatic expansion, isothermal compression, or adiabatic compression. So correct answer is what, we can say A is the right answer. Come to the next question. Suppose a particle trapped in a circular groove of radius 10 cm move along the groove steadily and complete 14 revolution in 50 seconds. The linear speed of the particle is, they are going to be asked about the linear speed. So what could be linear speed, my dear friends? What could be linear speed? A particle trapped in a circular groove of radius 10 cm move along a groove steadily and complete 14 revolution in 50 seconds. So my dear friends, you can say, sir, you know, V equal to R omega. R is by radius of curvature, omega is angular velocity, and V is also given by 2 pi f. F is here linear frequency, or F is given by 1 upon T. The number of cycle completed in 1 second is called is what, my dear friends? Frequency. Number of cycle completed in 1 second is called is what? Frequency, na? So this is also given by 2 pi f. Now my dear friends, simply we can say, sir, what is the frequency? How many cycle is completed? So 14 revolution in 50 second. 14 upon 50. That now 14 upon 50. Now this value is coming. So what will be the here? From that we can say, sir, if you are going to be calculate here, that is omega 2 pi f. Okay, so from there we can say, sir, omega is coming out to be 2 pi. Instead of f, can I write 14 upon 50? Yes, sir. And V is equal to what, sir? Omega r. So what is omega, sir? Omega is 2 pi into 14 upon 50. R is given how much? Radius is given how much? 10 centimeter. Just multiply it by 10. By solving, we will get approximate that value is coming out to be 18, and closest answer is what? 17.6 centimeter per second. So my dear friends, simple question it was. A particle was trapped circular groove of radius 10 cm, moves along a groove steadily and complete 14 revolution. It is going to be, suppose this is a particle, so it is going to be complete 14 revolution in 50 seconds. So they are going to ask the linear speed of the particles. They are going to be asked what is the linear speed. So you can say, sir, V equal to omega r. Right, r is radius of curvature, which is known in the question. Omega is given by 2 pi f. F is what? Frequency. Number of cycle completed in 1 second is called is what, my dear friends? Frequency. Number of cycle completed in 1 second. So 14 second in 50 second, 14 cycle in 50 second. So what will be frequency? You can say 14 upon 50. Omega is 2 pi f. You will get the omega. V equal to omega r, and directly you will get the answer. So easy question it was. Right, that question has been taken from the, we can say, from the linear frequency chapter, or linear frequency chapter 1 is there, frequency or vibration, sometimes we can say. From that one, that question has been taken. See, that is the next question, my dear friends. Suppose a body execute oscillatory motion. The displacement xt of the body from origin as a function of time is given by, xt is given, the period of the body is given by period. Okay, that data is here not important here. That data is here not important. Time period are given by 2 pi upon omega, na? Time period is given by 2 pi upon omega. So sometimes what's happened, my dear friends, the data is given just to confuse you. Okay, here a student can find, sir, why I am not going to use that one? Not necessarily, directly you can get the, na? So that data just going to be confused you. Right, 2 pi upon omega will get. So simple, you can get the answer A, no problem is there. Now that is the next question. Suppose n mole of ideal gas goes isobarically, means pressure is constant, from its initial stage T1 V1 to the final stage T2 V2. The work done during the process is, you have to be calculate the work done. So my dear friends, PV diagram, if you can say, this is P, that is the question has been taken from the thermodynamics 11th class. So you know, like that. So suppose that is 0.1, that is 0.2. So here P1 V1, here P2 V2. Okay, this is V1 V2. So what is your work done? Work done will be P V2 minus V1. So simply we can say, sir, here work done is what? P V2 minus P V1. What would be P? Can I write NR T2 minus NR T1? Just take common now. Just take NR T2 minus T1. Okay, here it should be better, it should write N bar. Okay, because here R is characteristic gas constant is not, but it is a universal gas constant, na? PV equal to nRT. Here N is number of mole, R is universal gas constant, not a characteristics. but in the option they have used the characteristic gas constant, but it should be it should be there universal gas constant 8.314 joule kg Kelvin mole. That value is going to be there. So simply we'll get that equation, right, and easily we'll get the answer is what? D. Come to the next question. What is the next question? Question is that suppose a block of 2 kg attached with a spring of a spring constant is 800 Newton meter. So one block is there. Okay, let's assume this is the spring and one block is there having mass is given 2 kg. The block is displaced to a distance of, by applying force, this block is displaced by the distance of 50 centimeter from the equilibrium position and released. It executes a simple harmonic motion. Once you are going to release, it executes the simple harmonic motion. The maximum potential energy of the block they are going to be asked. What is the maximum potential energy? My dear friends, try to be remember that point. Whenever they are going to be asked the what will be the maximum potential energy. So try to always keep in mind maximum potential energy given by half k x square, right? Half k x square. So just put that value half instead of k. So this is given, k is 800 Newton meter, Newton upon per meter, half k x square. So sir, x square na 15 upon 100 convert in the, because answer in the joule na, so SI unit. So just solve that. By solve A, you will get the value of 9 joule. Simply you are getting the 9 joule, B for Bombay. Okay, same question was asked in 2023. Here mass has been doubled, right? In that question 2 kg block, instead of 2 kg they have made 4 kg. Same force is there, so they asked what will be change in the potential energy. So my dear friends, potential energy half kx square. So it is independent from that one. So it is independent from that one. That question has been asked in 2023. Same question, that was that instead of 2, they are killing, initially block is 2 kg. After that, that 2 kg is block, it displaced by another body having mass 4 kg. So what will be the maximum potential energy of the block? So it will be half kx square. Try to be remember that one. For the same displacement, if the displacement is same, everything was same. So it is not going to depend on the mass. So 9 joule is the right answer. Try to be remember that one. That is the next question. A block of mass 0.4 kg is moving with a velocity of 6 meter per second and it makes the, see, that is another question on the collision. So what conclusion you can make? You can make, sir, conclusion is that till now, if the question that you have solved till now, one conclusion we can make that friction is important. Yes sir. After important chapter is what? Conclusion. After important is what? Collision. Another important is what? Friction. So till now, okay, as I am moving forward and after me, Binit sir will come with another chapter question like motion, projectile motion, all that. That all are important. So at the end you could be able to conclude that which chapter is most important, from which maximum question has been asked, and accordingly we can proceed your preparation, and simply you will get the result. No need to be to be much more details. Even the question is not going to be asked in the much more details. You can see na, just basics. If you have a basics, you could be able to do all that. Okay sir, no issue. Say another question is that a block of 0.4 kg moving with the velocity of 6 meter per second and makes a head-on collision with a stationary body of mass 0.8 kg. After collision, both the blocks move together. The final velocity with which they move will be. So my dear friends, simple. A block having mass 0.4 kg, suppose that is the block having mass 4 kg moving with the velocity of 6 meter per second, and it makes head collision with a stationary block, that is another block B having mass 8 kg. They are going to be a strike. After collision, stationary. So here velocity is 0. Initially it was stationary. After collision, both the block. After collision, what happening? Both the block. These block and these block, that is 0.4 kg. This is 0.8 kg. Moving with the same velocity. Block move together. So obviously they have some velocity. Final velocity v. So they are going to be asked. So my dear friends, here just use the conservation of momentum. So you can say, sir, m1 v1 plus m2 v2 is equal to what? It should be m1 plus m2 into V final, because both are moving with the same velocity. Do that. So m1 is what, sir? 0.4, moving with the velocity 6. Sir, m2 is 0.8 but moving with the velocity 0, and 0.4 plus 0.8 into Vf. By solving that, my dear friends, simply we can get now. We can say, sir, 2.4 is equal to 1.2 into V final simply. So V final will get 2 meters. So both will moving with the 2 meter per second. So what could be the answer, my dear friends? Here we can say 2 meter per second. That's why from the analysis now, that's why important that thing. Key analysis is why important, so that you could be able to give your preparation in the right direction with the right topic. What is required? That's why analysis is important. Now, so simple question was even we can do. So if the question, if any student is going to be read the collisions for the 20 of hours, yes, collision is a very huge topic. If they are going to invest 20 hours only for that topic, I don't think it is feasible. It will waste your time. So see the question pattern and do your preparation accordingly. Coming to the next question, that is the next question C. Another question is on the friction. What is the question? The block is kept on inclined plane of angle 30 degree. The coefficient of maximum static friction between the block and the inclined plane is 1 upon root 3. The acceleration of the block, your g is taken as 9.81 meters per second. You have to calculate the acceleration. So my dear friends, how we can do that? Simple question. We can say, sir, here that is the 30 degree, right? Let me see. A block kept on, that is the 30 degree. The coefficient of maximum static between the block and the friction is okay. So that is our one of the block. Here mg is acting. This is an perpendicular, that is your r, and in this it will be mg cos theta, because this is 90, so this will be 60, so it will be 30 now. So this is 30. This will be mg sin 30, and this one will be frictional force equal to mu into n. So what is the value of frictional force, anybody? Here frictional force is coming out to be mu into n, right? Mu into n. So mu is given 1 upon root 3. What is n, sir? mg cos 30. mg cos 30. Cos 30 is what, my dear friends? Root 3 upon 2 now. Cos 30. So sir, this is coming out to be mg by 2. That is the frictional force. Okay, see how much force acting in that way. So sir, mg sin theta in downward direction, so mg sin 30 equal to mg upon 2. So sir, both force are equal, na sir? Both force are equal, na sir? According to Newton's second law, when acceleration will comes, when there is an unbalanced force, na sir? When there will be unbalanced force, then only there will be no acceleration. Otherwise, either body will be in the static condition or it will move with the uniform velocity. Uniform velocity means no acceleration is there, right? So we can say, sir, what is the acceleration? 0, na sir? Because no any unbalanced force is there. Both are balanced. Either it will be in the static condition, or if it will move, then it will move with a constant velocity. That means uniform velocity. So no acceleration would be there. So correct answer is what, my dear friends? D for Delhi is the right answer, and I don't think we will find any difficulties in that type of question, right? Coming to the next question, my dear friends. See, that is the next question. Which of the following pair correctly describe the thermodynamics process? Thermodynamics process and their variables which remains constant. In isothermal, temperature remains constant. Yes sir. A. In isothermal, isobaric, pressure remains constant. Right. Isochoric, isochoric means volume is constant. That never means internal energy will constant. No. Adiabatic process, volume will be constant, not necessary. Energy will be, not volume. So what correct match? A and B. Yeah, simply. So in isobaric process, internal energy will be constant. No, my dear friends, not necessary. Why it is coming out to be? In the adiabatic process, what is happening? No heat transfer takes place, na? In adiabatic process, we can say, sir, no heat transfer takes place. So volume remains constant. No, that is isochoric process, right? Isochoric, we can say it is isochoric when volume remains constant. Right now, so it is not correct indicated. So correct answer is what? D. Which one is correctly describe or match? So A and B have been correctly matched. Coming to the next question. A particle moving in a simple harmonic motion, xt is given 2 sine 40t, where x in meter, t in the second, the maximum velocity. So simple question was there, my dear friends. Simply we can do. So we can say, sir, in the simple harmonic motion, xt is given, means displacement is given here. How much? Sir, displacement is given 2 or 0.t. Let me check. 2 sine 40t, sine omega t. So omega is what? 40t, right? 40t. So you have to get the velocity now. So what we can get the velocity? It will be d xt upon dt, dx upon dt na yaar, tell me na, dx upon dt. हाँ sir. So if you talk about dx upon dt, then what it is coming out to be? Thank you. Just differentiate that, my dear friends. So what is coming? Tell me. 2, simply we can say, sir, it will be 40 to ja 2 is to 40, sine will be cos omega t, 40t. So it will be 80 cos 40t. Now student will go through the answer 40t, they will go through the option chain. No, my dear friends, they are going to be asked the maximum velocity. Just use your mind. Just use your mind. They are going to use the going to ask the maximum velocity. So what should be the maximum value of cos theta yaar? What is maximum value of cos theta? We can say, sir, 1 na sir. So for maximum, that value, for V maximum, that should be maximum, and their maximum value is 1. So you can say, sir, maximum velocity I can get 80 is to 1, or coming out to be 80. So correct answer is what, my dear friends? 80 is the correct answer. Okay, so that way you have to be proceed in any question which is going to be asked. Clear na? So don't make so see now what easy question all are yaar. And that's why na I am telling you easily you can do, but the thing is that you have to be keep the consistency. You have to be cover your syllabus and then make practice. And really a question are easy here, even you can see. But yes, you have to be basics knowledge. You have to work on that, and for that mentor is needed. Mentor will help you in that case. Coming to the next question. A block of 20 kg is lying on a rough horizontal surface. A force 50 Newton is applied on the block horizontal, but the block does not move. The force of friction along the block is given by. My dear friends, again that question has been taken from the topic that is called friction. Again that question has been taken from the friction. So a block of 20 kg, right? 20 kg, a horizontal surface, force 50 Newton is applied here, 50 Newton. But block does not move. Okay, block is not going to move. That means we can say friction force equal to 50 Newton. Then only body is not going to move. Otherwise body will move na. Here see na. But the block does not move. So you know in the friction I will teach you one characteristics of friction. Friction force have capability to adjust themselves to their maximum value. Like suppose this is the body, I am going to apply the 2 Newton force. So if the body is not moving, that means 2 Newton is here is also going to be act. Now increase that force 4 Newton. Again body is not going to move. So now friction force become 4 Newton. Now suppose I am going to apply 10 Newton. Again body is not move. That means that friction is 10 Newton. So friction is going to be adjust themselves to their maximum value. What can be the friction maximum value? This is mu into n. That value they will adjust till that value. Once you are going to be you apply the force more than that value, the body will start moving. Na? The body will start moving. Getting or not getting mine? Clear? Okay. Coming to the next question. That is the next question, and again that question has been taken from the Mina is driving a car of mass m along a circular path. Okay, that is the motion from the circular motion. That question has been taken from the circular motion. Path of radius r. Okay, the coefficient of static friction between the tire and the car and the road is mu. Tire of the car and the road is mu. The maximum speed with which she can drive the car without slipping. Okay, What could be answer, my dear friends? So this is my friend Meena, who is going to be driving a car on a circular path. This is their car moving on circular path. So what is the maximum speed with which she can drive? Okay, she can drive the car without slipping. What is the condition so that there should not take place the slipping? To reduce slipping, my dear friends, you have to be just keep in mind friction force. Friction force, simply we can say, sir, F friction, or you get small f, friction force must be equal to centrifugal force. Then only it will not slip. Otherwise, whenever you talk about the circular motion, if you want to reduce the slipping, centrifugal force must be equal to the frictional force. Otherwise, body will going to be slip, right? So just try to be keep in mind that concept. So we can say, sir, F equal to what, sir? Frictional force equal to mu into N, and the sorry, centrifugal force is given by mv square r, na sir, and N is equal to mg, na sir. This is applying mg, na sir, and from that N mg, na. So mu mg equal to mv square upon r, and here we can say, sir, m se m will get cancel out. Okay, so you have to be calculate v, na. So root under r mu g, it is coming out to be simple mu rg, yeah. So what was the concept that you have to be just remember here? I will discuss that concept in the rotational motion, my dear friends. You have seen the maut ka kuआं, in Disneyland Mela. If you have visited, there might be some maut ka kuआं, death well in this. Bike is going to be revolved like that, or sometimes car in a circular path. They will use the same concept. They are going to use the same concept. That's why it is not going to be slip. And you guys think, yo, they have a what more? They are using the magic. No magic is there, yeah. Simple physics is involved there. No magic. Come to the next question. The length of a simple pendulum increased by 10%. Its time period increased by about. So my dear friends, simple question it was, that has been taken from the pendulum. One chapter is there. Time period is again given by 2 pi root under L upon G. Try to be remember, okay? That formula you have to remember. Time period is given by 2 pi root under L upon G. Now see, let's assume that quantity is x. Okay, let's assume that quantity is x. Let's assume x1. Okay. Next, you are going to increase the length by 10%. So let's assume this is t1. So what will be t2? So 2 pi instead of L, it will be 1.1 L upon G. So can you write it like that? Root under 1.1 into x1. Can you write root under 1.1 if you are going to be solved? But yes, no, there is a need of calculator here. Otherwise, you will find difficulties. Huh? Yeah, need of calculator. Otherwise, you find difficulties. So that value is coming out to be, my dear friends, I have solved 1.048 x1. Okay, so how much change? So we can say, sir, percentage now. So how much it is increases? 1.048 x1 minus x1 upon x1. So by solving that, we can say, sir, it is coming out to be 0.048 upon 100. So approximate 4.8% or close to 5%. 4.8% or close to 5%. So what could be the answer? A. But yeah, sometimes it's happened, my dear friends. Here without calculator, it will be very calculative. You cannot, in fact, you cannot able to solve that question. But no problem. Some question you can leave if the question is like that in exam. That is also the part of your, exam preparation. I will teach you that thing. See, okay, even if you are, you cannot do that type of question. No one. Okay, if you have a last time, at the last instant, if you have a time, little bit 1, 2 or 3 minutes, then go through that type of question. But initially, don't waste your much more time, because in the recently trend you have seen for the general, out of 120, how much cutoff is coming? Approximate 100 marks. So out of 120, 100 marks is a good. So if you are going to waste your time on that type of question, at the end you will not get sufficient time, and the attempted number of question will be less, and you can be the rejected. That's why that type of question will be deal at the end if you are getting time. but that type question is coming very less. Even anyone cannot solve. If anyone is going to be solved just by assumption, that is on their kismat. Either it can be correct or it can be wrong. Yeah, that is the next question. The pressure P of an ideal gas RMS VRMS is reduced to P by 2. Isothermal process, the root mean square velocity, my dear friends. VRMS root mean square is given by, please try to keep in mind, root under 3RT upon m naught. M naught is molecular weight. This is what? Molecular weight. T is temperature. So sir, it is not going to be depends on the pressure. No, it is not going to be depends on the pressure. We can see here, not going to depend on the pressure. So it will be 1 only itself. It is not going to be depends on the pressure. Simply we can do that. That is the next question. Sunlight passes through Earth atmosphere. It gets scattered by particles. For a light wavelength lambda, the amount of scattering is proportional to. So my dear friends, that question we can take through the Rayleigh scattering. Rayleigh scattering. In thermodynamics, I will teach you about that Rayleigh scattering. According to that, my dear friends, scattering is directly proportional to 1 upon lambda ke power 4. Okay, 1 upon lambda ke power 4. So you will get the answer is what? P for Bombay. That is the part of thermodynamics. In the thermodynamics, I will teach you that concept. Next question. What is the condition of two vectors to be collinear? What? You have to make them what? Collinear, right? So the vector should have same initial point, vector should have same magnitude, the vector should be parallel to the same line. Yes, Chennai is the vector should have parallel to the same line, then it will be called collinear. So it was again easy question. Which of the following electromagnetic wave or rays has the minimum wavelength? Try to remember. Gamma. Maximum is red, minimum is what? Gamma rays. Wavelength na? So gamma. So D is the right answer. That is question from the electromagnetic wave or wave chapter. Wave optics is there, where I will see there. That is the next question, my dear friends. Rahul, mass 60 kg, is standing on a frictionless plane surface. He kicked a box of 2 kg lying near to his feet. Giving its velocity of 3 meters per second, the velocity of Rahul after kick will be. So my dear friends, that question again we can understand that is taken from the conservation of simply we can say conservation of momentum, or conservation of momentum. From that question has been taken. So if you use the conservation of momentum, so we can say sir, m1 v1 plus m2 v2 is equal to m vi le lo, that will be better. M2 vi, or what better I can do, Rahul na. So let's assume m r v r I plus she kick of y. So mb mass of y into v y initial, giving its velocity of how much, my dear friends? Giving it velocity of after that what is happening, their velocity is how much my coming out to be, my dear friends? So simply we can say sir, it is coming out to be m r v r f plus m b v b f. Just put the value. So sir, m r what? 60 kg. What is their velocity? Frictionless. He is m r 60, standing on a frictionless. Okay, standing. So it is a stop 0 plus m b v b. So initially it is also 0. Because after kicking it is going to be no m r v r. M r Rahul, what is 60? What is their velocity? So that's what is their velocity? I need to calculate. Plus mb. What is mb, my dear friends? So how much kg? MB 2 kg now. So 2 moving with the velocity is how much? 3. So from there what we can get, my dear friends? We can say sir, 0 is equal to 60. This is given 3 na. 60 v plus 6. So V equal to minus 6 upon 10 means minus 0.1 meter per second. So coming out to be what, my dear friends? Minus 0.1 meter per second. A is the correct answer. Okay. Yes. So now let's take a next question. So what is that question, my dear friends? The question is that two bodies A and B of masses 2 kg and 6 kg is contact with each other, rest on a table against a rigid wall. We can see the diagram is given here. The coefficient of friction between the bodies and the table, mu is known here, 0.20. A force of 200 Newton is applied horizontally. That force, find the net force on the partition. You have to calculate the net force on the partition. Okay. So my dear friends, that is the easy question. That question has been taken from the friction. One chapter is there in the 11th physics, friction is there. So that question has been taken from the friction, and from the very earlier I used to say that friction is important. Every year you are going to find the question from the friction. So how we can solve that, my dear friends? How we can solve that? We can say, sir, if given data, mass of A is given 2 kg, right? Mass of B is given how much kg, sir? I think 6 kg. Okay. And one force is going to be applied, and that force is here, 200 Newton is going to be applied. And coefficient of friction is given here, 0.2 between the block, and so here mu is known, 0.2, right? A force itna is applied. Find the net force on the partition. What will be net force there on the partition? That question is going to be, you have to be calculate. Okay, my dear friends, as the force is acting in that way, so the friction will try to oppose that motion. So what will be the frictional force direction? So it will be the frictional force direction. What is frictional force, my dear friends? You can say, sir, mu into n, right? Mu into n. In the question, mu is known, and what is n? N will be the masses of these two objects. So we can say, sir, mu instead of n, what is here? We can say, na, sir, this is 2 kg, so it is 2 into g, and this is 6 kg, so 6 into g. So what is total? 6 into 8. You can simply say, na, 8 g. So we can simply say 2 plus 6 m into g. So from there you are getting the friction force, and that value is coming out to be 0.2 into 10 into 8. By solving that, you will get the frictional force is coming out to be 16 Newton. That is the frictional force, and that is the applied force. Applied force is 200 Newton, and this is coming out to be 60 Newton. So what is F net, my dear friends, at the partition? So you can say the applied force minus of frictional force, right? Frictional force Ft, you can say F, small f. So what you can do? You can do 200 minus 16. It is coming out to be 184 Newton, right? So the correct answer is what, my dear friends? C4 Chennai. So it was an easy question, very easy question. In fact, what you have to do is simply you have to proceed by using the concept, and you will get the answer. So it was easy question. As I used to say, mostly question are easy. Some little bit calculative question is there, like that question. It is also not a calculative. From the diagram, a student get feared how to proceed in that question, but really that is also one of the easy question. So let's see what is the question, then I will come to the solution part. The question is that a rear side of truck is open, rear piche side, right, is open. A box of 30 kg mass is placed at 4.5 meter away from the open end. So we can say that is the truck, and that meter from there to there, that is given in the question, is 4.5 meter. From that point to that point, this is given, the distance is 4.5 meter. The coefficient of friction between the box and the truck, the coefficient of friction mu is given here, 0.20, as usually this value is same. On a straight road, the truck start from rest. That means the initial velocity of truck is 0, because starting from the rest, and accelerate with 3 meter per second square. What is acceleration of that truck? Acceleration of a truck is 3 meter per second square, right? At what distance from the starting point does the box fall off the truck? Ignore the size of the box, and that all that data is there. So my dear friends, just use the concept. Very easy question it was. Don't be feared by seeing the diagram. From the Newton first law, you might have listened that inertia law is law of inertia. What is that? It say whatever body in the situation, they will try to maintain their condition. So initially it was in the static condition, right? As the truck will accelerate, So what is happening, my dear friends, they will try to be in the static condition. Because of that, they will move in the backward direction, and one time you will reach that, they will fall from the truck. Now the question is that when that will fall over the ground or on the ground, during that how much distance will be covered by that truck? That is your question, my dear friends. So first of all, what you have to be do in the question, my dear friends, simply we can say, sir, I know here maximum friction force is what? If I will ask the frictional force which is acting there, so friction force is what? Mu into n. Mu into n. What is the weight? 30 kg na. So okay, 30. So mu is given 0.2. 30 into g na, into 10. 10 is given, okay, 10. So friction force is coming out to be how much, my dear friends? By solving that, I think you are getting 60 Newton, right? Yeah, you are getting 60 Newton. Okay. Now the question is that what is the force applied when the acceleration is 3 meter per second squared? So we can say, sir, I know force applied on that body, applied force, capital S, applied. So that will be F equal to ma, right? M into A. So applied force is, sir, applied force is what? Mass of the object, this is given 30 into A, how much? 3. So that is coming out to be 90 Newton. How much it is coming out to be? 90 Newton. This is in that direction. Okay. Now come to the next question, my dear friends. Now I will ask, what will be the net force? What will be the net force? So we can say, sir, F applied minus of F of what? Friction force, right? So by solving this, we can say it is coming out to be 30 Newton. Now one more thing, we can say 30 Newton. Okay, so that is the net force. So what is the acceleration of that body? So simply we can say, sir, F equal to ma, m into A. This is 30, m is given 30. So what is the acceleration of the object? That was the acceleration of the truck. Acceleration of the object, that will coming out to be 1 meter per second square. Now 1 meter per second square. Now tell me, as during that, how much distance they have to be covered to fall down? So 4.5 meter. So can I use S equal to ut plus half AT square? Can I use? Yes, sir, because after that distance they will fall down. Right, sir. So S is given how much? This is given 4.5 ut. So initially starting from the rest, so it will be 0 plus half A is 1 T square. So from there, can you get the T? By solving that, we can get the value of T, and T is coming out to be 3 seconds. Now during 3 seconds, that second, how much distance covered by that truck? Tell me. So we can say distance traveled by truck, this is given as equal to ut plus half AT square, right, sir? Okay, sir. So sir, u is 0 na, sir, starting from the rest. So S1 is equal to half A. A is what? 3, truck. 3 into how much? 3 3s are 9, right? 9 3s are 27. 27 upon 2, 13.5, right now, 13.5. So yeah, during that the truck will cover the distance of 13.5. So A is the right answer. So we can see, just move with your concept only, just go through the concept. Don't be feared by seeing the question. It is a tough, okay, from the diagram I know a student will stuck. Oh, what a difficult diagram is there, right? They will think, how much difficult diagram. So just trust on your concept and use the concept, and you will get the answer accordingly. So don't worry about that, okay? So it was a little bit calculative, but concept was not a bigger, easy concept was involved there. So next, coming to the next question, my dear friends, which of the following is correct expression for maximum possible speed of a car on a banked road? There is a 3 or 4 page derivation, my dear friends. I will use to drive that one, bank road. Some tilted is there whenever you are going to turn. So some tilt is there, right? On the highway you might have seen, whenever there is a turn, there will be some tilted part, right? So that is called banking. So I am not going to derive just now, otherwise derivation is there. I used to say in the class, try to remember that formula that is coming after the derivation. It will take longer time, so just try to remember that one. Even in the class I will tell, after derivation I will do in the derivation, then I will ask you to remember that data. That is the next question. That is the, my dear friends, what next question? What is next question? Question is that a 60 kg man stand in a contact against the inner wall of a hollow cylindrical drum of radius 4 meter rotating about its vertical axis with revolution 180 revolution per minute. Well, the coefficient of friction between the wall and his clothing is 0.20. Find the minimum rotational speed of the cylinder to enable the man to remain stuck to the wall without falling when the floor is suddenly removed. When the floor is suddenly removed, assume G is given here, my dear friends. So this is something like that way, okay. And here one people is going to be standing with the inner from that one. So the question is that the minimum rotational speed so that it will not fall down. So my dear friends, what is in that when they will rotate, what will be the weight. The weight is simply we can say, sir, mg, simple. F is equal to what, my dear friends? Centripetal force. What will be centripetal force? So centripetal force will be, my dear friends, mr omega square, mr omega square. And my dear friends, what is frictional force? Frictional force equal to mu into centrifugal force. Frictional force simply we can say here, this is frictional force, mu, okay, mr omega square, and you have to be just keep in mind that frictional force should be equal to mg, then only they will not fall. Frictional force should be equal to weight of body, then only that will not fall, otherwise they will fall down. If so, friction force will, when they will come down, friction force oppose and they will try to be reduce their motion, try to be stop in the motion. So Fs is coming out to be mr omega square. So mr omega square. Body is what, my dear friends? mg. Now tell me, mg. So mr, what is the mass? A 60 kg man. Okay. So get cancel out now. No use of that one. So simply I can say omega square equal to G by R, right? G by R. So what will be omega? Omega will be root under G by R. The value of G is given how much? The value of G is given how much, my dear friends? 10 cylindrical drum of radius 4. So G upon R, omega squared, and here mu is also there, na? Here one mu is there, mu. So make that correct. Simply we can say, sir, mu is there, na? So sir, omega square directly I can write G upon R into mu. Put the value all that, and by solving that we will get coming out to be root under 12.5 meter radian, omega na radian per second. So that is your answer. Omega is equal to root under 12.5. So their velocity omega should be root under 12.5. Then that man will not fall, even the floor will be removed from that one. So that was just a value, in that that centrifugal force, frictional force equal to mu or that one mg, centrifugal force. Just do balance these two and you will get the answer. That is the next question. Question is that two capillaries whose diameter are respectively 9 mm and 8 mm stand one by one in water. If water rises to a height of 4.5 mm in the first capillary, what will be the height of the water in the second capillary? Two capillary whose diameter respectively 9 and 8 mm, right? Rest thing is fine. So that question has been taken from the fluid mechanics. One chapter is there, topic is there, capillarity. So capillary rise is given by, my dear friends, 4 sigma cos theta upon rho GD, right? Rest thing is fine, everything is constant. So can I say H is proportional to 1 upon D? So can I say HD equal to constant? Yes. So can I say H1 D1 is equal to H2 D2? h is capillary height. Yes sir. Sir, obviously I can say. So from there can I say h2 upon h1, h2 upon h1 equal to d1 upon d2. The all that data is there. H2 upon 4.5 is equal to 9 upon 8. From there we will get the value of h2. It is coming out to be 5.66 into 10 to the power minus 3. 5.66 into 10 to the power minus 3. So 5 point okay, that A is the right answer. So you know capillarity, whenever suppose that is the container in this, at that level water is filled, whenever you are going to insert a small tube diameter, then the level of water in the tube will be either higher or lower than that of general level. That is called your H or capillarity. That is called your H or capillarity. So that was even easy question. Whenever that type of comparison question is coming now, so see in that, whenever, not even in that subject, everywhere, whenever the comparison of two things is coming now, so see the data which is going to be changed, because the rest quantity is same, so it is same for both the case. So see the parameter or quantity which is varying, which is going to be changed. So here D is going to be changed. So I have got the relation with the D, and accordingly I have moved, and you have get the answer. That is the next question, my dear friends. A static friction is self-adjusting force up to its limit. Which limit? Maximum limit. Like you, suppose this is the body, you are going to apply the 5 Newton force, body is not moving, that means frictional force is 5 Newton. If you are moving, the force is 15 Newton. Suppose again body is not moving, that means friction force is going to be opposed, and that value is coming out to be 15. But till which value? So here you can say the friction is going to be adjust themselves, but till which value they can adjust? They can adjust up to the value of mu into n, that is the limiting friction, or you can say the maximum static friction or limiting friction. To that they can change their value, adjust. So we can say that one. Okay, note put without being sure that maximum value of a static friction is coming into play. So Fs equal to mu into n. Yes, Chennai is the right answer. C for Chennai is the right answer. Coming to the next question. Okay, so what is the largest average velocity of blood flow in artery radius? That one, if the flow must remain laminar, also determine. Okay, viscosity of blood is given here, my dear friends. So in this, what you have to be do? Tell me. Here radius is given. Okay, do one thing. Can you comment here what the proceed you have to be in that question? Coming to that one. Next question. A stream of water flowing horizontally with a speed of 20 meter per second pushes out a tube of cross section area 10 to the power minus 1 meter square and hit at a velocity vertical wall. Find the force exerted on the wall by the impact of water, assuming that it does not rebounds. So my dear friends, in that case, okay, I think data is mistake, not given even in the question. No data is here, but it was the fault of question. Okay, let me see that question. I think that is the note mistake of typist. I think that was the question like that. Even note option was present there. But in that question what you have to be do, first of all, here in that question what you have to be do, calculate dm upon dt. Okay, after that rate of loss of momentum. Loss of momentum is given by dm upon dt into velocity. From that we will get the answer. Velocity is here given, density is also, even dm upon dt, this is given by rho a v, na, rho a v, rho a v, right. Coming to the next question. The escape velocity of a body of mass 1 kg from earth surface is 11.2 kilometer per second, the escape velocity of the body of mass 100 kg would be. You know, my dear friends, if you go through the formula of escape velocity is given by root under 2 g m upon r. Here g is gravitational constant, r simply we know radius, m is mass of the planet. What? Mass of the planet. Here m is mass of the planet. So my dear friends, you know, here one mass is 1 kg, another one is 10 kg. So that is escape velocity independent of the object mass. That is just going to depends upon the planet mass, over which you are going to be, you are going to be escape of anything. So what should be the minimum value? It is coming out to be 11.2 kilometer per second. That is not given, that notes going to depends upon the mass of the object which is going to be escape out. That is just depends upon the mass of the planet over on which gravity is there, and against that you have to be flow of anything which will never come in the due to the gravity of the earth. Anything if you have to be removed from the gravity of the earth, you have to be give the minimum speed, that must be escape velocity, and this is always 11.2 kilometer per second. That doesn't matter what is the mass of object. It can be rocket, it can be you, it can be 1 kg block, it can be 1 quintal block, it can be 100 quintal blocks, right? Everyone, if you are going to give the 11.2 kilometer per second, they will never return back to your gravity. They will escape from the gravity. That is called escape velocity. Next question. The temperature of the reservoir of a Carnot engine operating if it is 70%. Okay, that is the question from the efficiency of Carnot cycle question has been taken. So Carnot cycle efficiency 1 minus TL upon TH. TL is lower temperature or sink temperature, that is called source temperature. So in the question 70%, that means 0.7 is given, 1 minus TL upon TH 100,000 Kelvin. So from there I you will just get calculate now. TL upon 1000 is coming out to be how much? That is coming out to be 70% now. So 1 minus 30%, 0.3 now. So TL is coming to be 3 into 1000, 300, right? So A is the right answer. So that question has been taken from the Carnot engine. That is a part of thermodynamics. I will teach you in the thermodynamics. I will teach you about that. Then we will see their detailed solution. Okay, how you have to be. This is just a Carnot engine, and this is the simply we can say TH. From there, this is the engine, and that is your TL. So you will get the W. The energy is coming QH, going QL, and you will get the W. In BCC structure, the packing fraction is actually that is coming out to be 68%. That is a question of material. So coming out to be C. In BCC structure, packing fraction is that how much portion of the unit cell is covered by the or occupied by the atoms. What is atomic packing fraction? So it is the portion of the unit cell which is occupied by the atoms. That is called packing fraction. It is coming out to be 68%, and that result you will get. So see this question. Two springs are connected to a block of mass m placed on a frictionless surface as shown below. If both the springs have a spring constant k, the frequency of oscillation. Frequency is given by, my dear friends, simply you have to be remember 1 upon 2 pi root under m by k. Okay, so here we can see this m is there. Now m is there, and just use the formula, and it is coming out to be that one. Next, it is coordinate system is attached to a rigid body, and one describe the position of any particle relative to its, then such coordinate system is called as, this is called frame of reference. Okay, so my dear friends, that all are about my topic. After that, Beneath sir will come and they will take the next question to carry forward, right?
Hello everyone. So the first half of the question has been done by the Rajesh sir here. Okay, so the remaining half question I am doing. I'm going to continue here. Okay, so let us start with the first question. So here you can see the first question is, an object starts from the rest and moves along a straight line with a velocity Vt is equal to 27 minus 3t square here. Okay, now what we want to calculate? We want to calculate the value of the acceleration at the instant it stops here. So now, as you know, the acceleration is nothing but it is defined as the rate of change of velocity. So I can directly write the A is going to be equal to dv by dt. Okay, this is going to be the acceleration here. So now if you just take the differentiation of the velocity, you are going to get the expression as minus 6t here. Okay, so this will be the acceleration at any particular point of time here. So now in this case, what do you want to find out? You want to find out the value of the acceleration at an instant when it stops here. That means the velocity of the system is going to be 0. So first of all, we need to calculate at what time the velocity is getting 0 here. Okay, so now if you see, the velocity is getting 0, at, so it can directly be calculated by equating the velocity equal to 0 here. So if you solve it, you will see that the t is coming out to be 3 seconds. So that simply means after 3 seconds, the body is going to have a 0 velocity. So therefore I can say the acceleration at the instant when it stops is equal to minus 18 meter per second here. Okay, so this will be the answer of this particular question. So I can say the option number A will be the correct answer here. So that's a very simple question here. Now let's see the next part. So in the next question, what is given to us? In the second question, we have been provided with the position of a particle is given by a ri vector plus 4t square j, where t is in second, and you want to find out the value of the velocity at time equal to 1 second. Okay, so we know the initial position vector here. So you can see the r is given as 6i plus 4t square j. Okay, so I can directly write the velocity is going to be equal to change in rate of change of position vector here. This will be the velocity. So therefore the velocity vector will be given by, you can simply write the velocity vector will be 6i plus 8t j cap. So this is going to be the velocity vector. Okay, so now if you see the option very carefully, you can see the options are given in the magnitude here. So that means we have to find out the value of the magnitude of the velocity. So at time equal to 1 second, we can say at time equal to 1 second, the velocity vector is going to be equal to 6i cap plus 8j cap. Therefore the magnitude of the velocity will be 6 square plus 8 square under root, and the answer will come out to be as 10 meter per second. Okay, so therefore the option number A is going to be the correct answer of this particular part. Okay, so again this is a very simple question. So now let us do the next question here. An object of 2 kg has a velocity of 5 meter per second I cap, 5 meter per second I at t equal to 0 second. Its velocity becomes 7 meter per second at 4 second here. So that means you can observe the velocity is being changing here. So at the initial time, at time equal to 0 second, the velocity is given to you as 5 meter per second, and at time equal to 4 second, you are observing that the velocity has been increased to 7 meter per second here. Okay, so therefore the work done on the object can simply be calculated by, okay, just see the mass has been provided to us, the velocity has been provided to us. So in this case we have to calculate the value of the work done by using the work energy theorem. Okay, so according to the work energy theorem, the work has been equal to the rate is equal to the change in kinetic energy. Okay, so first of all you have to calculate here the initial and the final kinetic energy, and if you just take the difference of this kinetic energy, then you will get the value of the work done here. Okay, so here you can see this is the formula you are going to get of the final work done. So just put all the values into this expression and you will get your final answer. So mass is given to you as 2 kg, the final velocity is 7 square and initial velocity is 5 square. So if you just simplify it, you will get the work done is coming out to be as 24 joule here. Okay, therefore the option number A is going to be the correct answer in this case. Okay, now the next part. Now in this question you can see the temperature of the bottom and surface of the lake 50 meter deep is given to us, that is 7 degrees Celsius and the 27 degrees Celsius. So let us say this is the free surface of a lake. So this is representing the free surface. Now here I am marking the let us say this dotted line is representing the bottom of the lake here. Okay, so let us take the bottom of the lake as 1 and the top of the lake as point number 2, and the vertical distance between these two lines, between these 2 points, is 50 meter. Now in this case, what do you want to find out? So the temperature is given to us at the bottom as well as at the top here. So you can see at the temperature we have, at the bottom we have a temperature of 7 degrees Celsius, that simply means 280 Kelvin, and at the top we have a temperature of 27 degrees Celsius, that means 300 Kelvin here. Okay, this is the temperature limit here. Now along with that we have been provided with an air bubble which is having a volume of 1.7 centimeter cube at the bottom. So let us say we have a bubble, so this is our air bubble, and I can directly write the air bubble is having a volume of 1 centimeter cube at the bottom of the lake. Now what will be the volume of the bubble if it is rising on the top of the lake here? Okay, so now you can see as we are moving upward, as we are moving in the upward direction, the corresponding pressure which is acting on the bubble is going to be reduced. Okay, because according to the hydrostatic law, as soon as you are moving in the downward direction, the corresponding pressure will increase. Okay, and due to the increase in pressure, the corresponding volume will decrease here. So I can directly write even though the volume is changing, but the number of moles or the mass is not going to be changed here. So I can directly write the number of moles at the bottom position and at the top position is going to be remain same. So I can directly write the ratio of P1 V1, the ratio of P1 V1 divided by R bar T1 is going to be equal to P2 V2 divided by RT2. This is a formula you are going to get. Okay, because we are talking about the air bubble here. Now in this case, the point number 1, the subscript 1 is representing the bottom of the lake here. Okay, and you can see in the question it is given that the atmospheric pressure is having a value of 10 to the power 5 Pascal. So first of all, whenever you are doing the question related to thermal engineering, you have to always remember that you have to take the pressure in the absolute form here. Okay, so we have to take the pressure in the absolute form at the point number 1 and at the point number 2. So I can directly write at the point number 1, the pressure is going to be equal to atmospheric pressure plus the pressure due to increase in the height here. So it will be equal to rho g into h here. So this is the pressure at the outside of the bubble at the bottom of the lake here. Okay, and the corresponding volume is given to us, that is 1.4. R is not going to be changed, R is going to be remain constant, that is why I am not cancelling it out, and the temperature is 280 Kelvin here. And similarly, if you see at the top of the lake, we are having only the atmospheric pressure. The atmospheric pressure is having a value of 10 to the power 5 multiplied by volume we have to calculate. R is going to be remain same and temperature is 300 Kelvin. Okay, so this is going to be the final equation in this case. So you just have to solve this particular equation and you will get your final answer. So I can directly write the R bar will be cancelled out, and the volume of the air bubble at the top of the lake is going to be equal to, so this answer is coming out to be equal to around 9 centimeter cube here. So if you just solve it, you will get this final answer. Okay, so just do the calculation and you will get this answer here. So that's again a very simple question here. Now the next part, a particle starts from the origin at time t equal to 0 second with a velocity of v equal to 5I. So I can directly write the body is moving, the particle is moving along a horizontal distance here. Now it moves in a xy plane under the action of force here. Okay, so I can directly write the body is moving in the horizontal direction, okay, but a force is acting on the body here, okay, and it is producing a constant acceleration of a is equal to 4i plus 2j here. At what time is a particle coordinate is 16 meter. So what is saying here, basically the force is acting on the particle and the particle is moving in the xy plane now. So now how much time it is basically taking when the particle coordinate is 16 meter here, okay. So now see, here we have to use the laws of motion, and generally we have 3 laws of motion here, okay. So now we have been provided with the distance covered by the particle in the vertical direction here, okay. So I can directly write the y is going to be equal to ut plus half at square, okay. So this is a simple equation, the simple law of equation you can use here, okay. So in this case you can see in the vertical direction the velocity is not having any velocity here, because the initial velocity is only along the x direction here. So I can directly write the y is given to you 16, the particle has covered the 16 meter of 16 unit distance in the y direction, and the velocity in the y direction is 0 at the starting position here, and in the y direction the acceleration is given to you as 2j here, and correspondingly time we have to calculate. So if you solve this equation, you are going to see the time taken by a particle is coming out to be 4 seconds here, okay. So I can say the option number A is going to be the correct answer of this particular part here, okay. So again this question is very, very simple here. Now the next part is the potential energy of an object is given by u equal to minus cx plus dx square, where c and d are the constant and the force acting on the object is given by. So again, so that's a very simple formula based question here. So first of all you have to remember that the force which is acting on the particle is going to be equal to the rate of change of potential energy here, okay. So you just have to do the differentiation of the potential energy which is given to you. So just differentiate it and you will get your final answer here, okay. So just if you just differentiate it, you will get the answer as c minus 2dx, c minus 2dx. So this is the force which is going to be act on the object here. So option number A, c minus 2dx, is going to be the correct answer in this case here. Now the next part, a small object makes uniform motion with the frequency v in a circle of radius r. The magnitude of its acceleration is. So now just read the question very carefully. A small object is making a uniform motion in a circle. That means this question has been framed from a uniform circular motion here, okay. So whenever a body is moving with a constant velocity around a circle here, in that case you have to remember that there will be no tangential acceleration, because whenever a body is moving there are 2 types of acceleration which is acting over the body here. The first one is the tangential acceleration and the second one is the centripetal acceleration here, or we can say the radial acceleration. So the tangential acceleration always act tangent to the circle here, okay, which is always due to the change in the magnitude of the velocity here, okay. And we have a centripetal acceleration which is there due to the change in the direction of the velocity here, okay. So now in this case we are the body is observing the uniform circular motion, so we can say the only acceleration which is going to be there is going to be the centripetal acceleration here, okay. And the formula of the centripetal acceleration is just wait a minute. Yeah, so in this case the magnitude of the coriolis acceleration will the magnitude of the centripetal acceleration, it is going to be equal to v square upon r, or you can write omega square into r. That is the formula of the centripetal acceleration, okay. And always remember that if there is a body, if the body is moving with some angular acceleration, then only we are going to observe some tangential acceleration, okay. If there is no angular acceleration, the body is not going to have any tangential acceleration, but the centrifugal action is always going to be there when a body is moving or in a circular motion here. Now the next part is how do we calculate the velocity here. So velocity is very, very simple. You can simply say the velocity is nothing but it is the distance covered by a body divided by time here, Okay, the speed is nothing but the distance covered by a body divided by time. So I can write the distance covered by the body will be perimeter 2 pi r and divided by time here. Okay, and in the question we have been provided with the value of frequency also. So we already know that time period is equal to 1 by v. Okay, so I can write the velocity is going to be equal to 2 pi r multiplied by nu here. So this will be the velocity or here in this case. So the acceleration, the centripetal acceleration will going to be 2 pi r nu square divided by r here. So if you solve it, you will get your answer as 4 pi square mu square into r here. So this will be the final answer you are going to get in this case. Okay, so option number B is going to be the correct answer in this case here. Okay, so again the question is very simple, and this is from the uniform circular motion here. Okay, so now let's move to our next part. A ball of 2 kg is acted upon by a force which is having a magnitude of 10 Newton, and this force is acting toward the east here. Now the acceleration is of the ball is toward the. So now just see the mass, the ball is acted upon by a force in toward the east direction here. Okay, so we can say the body is going to be accelerate only in the same direction. Okay, it is going to be accelerate in the same direction, and we know that the force is basically equal to mass into acceleration. So we can say the acceleration is going to be equal to force upon mass, and the force is given to you 10, mass is given to you 2. So we can say the acceleration is going to be equal to 5 meter per second square toward east here. Okay, so option number A is going to be the correct answer in this case here. So that's again a very simple question here. Now the next part is this one. Suppose a cannon of mass 600 kg fires a cannonball of mass 5 kg with a speed of 40 meter per second here. The recoil speed of the cannon is. Okay, so now just see. This question is related to the conservation of momentum here. Okay, because the cannonball has been fired from a cannon here. Okay, and when the cannonball is moving with some velocity, it is going to with some momentum here. Okay, and now in this entire system the momentum is going to be conserved. So I can say the same momentum is going to be conserved by the cannon also. So I can directly write m1 v1 plus m2 v2, the conservation of momentum equation, is going to be 0. So you can see the mass of the cannon is 600 kg. We don't know with which velocity it has been recoiled here, and the cannonball is having a mass of 5 kg. Velocity is given to us 40. Okay, just wait a minute. Yeah, so here I am going to take the sign consideration also. 5 minus 40 equal to 0 here. Okay, because the velocity, the cannonball is moving in the positive x direction. If it is moving in the positive x direction, then the cannon is going to move in the opposite direction here. Okay, so if you just solve it, you are going to see the velocity with which the cannon is recoiling is going to be equal to 200 by 600, and it will be equal to 1 by 3 here. So option number D is going to be the correct answer in this case here. So that's again a very simple question. Now the next part. In the following equation, x equal to a exponential to the power b minus b into t, where t represent the displacement, L and t here, x and t are representing the displacement and the time here. To make the given equation dimensionally consistent, dimensionally consistent equation simply mean the dimensions of this expression in the left hand side and the right hand side has to be same. Okay, now in order to make the equation dimensionally consistent, what should be the dimension of a and b here? So now you can see the equation is given like this one here, a exponential minus b to the power t here. Okay, so can I say that the first of all the dimensions of the x is meter, that it is going to be length here. Okay, it is a displacement, or I can say distance here. So now the same unit is going to have the a is also going to have the same unit. So I can directly say the a is also going to have a same unit, that is L here, and correspondingly the exponential to the power minus b into t, this term is going to have a no dimensions here. So if the T is having a dimension of capital T, so I can say in order to make the non-dimensionless, in order to make the dimensionless, the B has to have a unit of T minus 1 here. Then only after multiplying these two terms, we are going to have a dimensionless term here. Okay, so therefore I can say the A is going to have a unit of length here, okay, and B is going to have a unit of T inverse here. So that means the option number B is going to be the correct answer in this case, L T minus 1. Now the next part, the distance traveled by a car is given by the equation x equal to a plus bt plus ct square. X equal to a plus bt plus ct square. Now what will be the dimension of a, b and c here? So first of all, just see again, in order to make the dimensionally consistent equation, the left hand side and the right hand side equation has to unit has to be same here. Okay, so if the unit of x is L, so I can say the unit of each and every term, the first term, the second term and the third term, all of these three terms should have a same unit. Okay, because the two terms which can only be added and subtracted if they are in the same units here. Okay, so I can say the A is going to have a same unit as x here. Okay, now the product of B and T, the product of BT should have a same unit as L here. Okay, so I can say BT, it should have a unit of L here. Okay, and we know that T is having a unit of time. So therefore B is going to have a unit of LT minus 1 here. Okay, because if you just multiply this B term with the time, then only you are going to have a units of length here. And in the same way I can say the unit of C, T square, should be equal to L here. Okay, therefore I can say the C should have a unit of LT minus 2 here. So therefore the option C, LT minus 1, LT minus 2 is going to be the correct answer in this case here. So again a very simple question. Now the next part, starting from the rest, if a system undergoes a one-dimensional motion with acceleration proportional to t square, where t is the elapsed time here, the power delivered to it at time t is proportional to. So now we know that acceleration is directly proportional to time here. Acceleration is directly proportional to the t square. Now we have to calculate that power is directly proportional to t to the power which power here. Okay, now we have to calculate that what is the value of n here. So in that case you can see, in order to remove the proportionality sign, what I have done, I have just introduced a constant a is equal to kt square. Okay, and what is the formula of power? Power is defined as the force into velocity. That is the formula of the power only. Okay, so we can say the velocity first of all we have to calculate, and it is equal to acceleration time here. Okay, and its integration. So if you just perform the integration, you are going to see that velocity is coming out to be as kt cube plus constant. This is going to be the velocity here in this case, and correspondingly I can write power is equal to force into velocity, which will be equal to mass into acceleration multiplied by velocity here. So you can see acceleration is kt square, velocity is half 1 by 3 kt cube here. Okay, therefore I can say the power is going to be directly proportional to t to the power 5 here. So option number C, that is value of n is going to be the 5 here in this case. Now the next part is question number 13. So in this case the position time graph of an object moving in the uniform motion is a straight line parallel to the position axis, straight line passing through the origin with an angle 45 degree with the time axis here. So now in this case just see, we have to draw the position time graph. Now what is the meaning of position time graph here? Position time graph simply means the graph between the displacement and time here. So this is the position time graph. Okay, Now a body is moving with a uniform motion here. Uniform motion means the body is moving with a constant velocity. So if the body is moving with a constant velocity, that simply means this graph is going to start from a origin, and it is going to be shown like this one here. Okay, so you can see the slope of this line is nothing but is equal to v, which is equal to dx by dt. Okay, so I can say the position time graph of an object moving with uniform motion is a straight line passing through the origin with an angle 45 degree with the time axis here. Okay, why only 45 degree? Because it is covering the equal amount of distance in an equal amount of time here. That is why. Now the next question. The distance transferred during the equal interval of a time by a body falling from rest stand to one another in the same ratio as. Okay, so basically it is asking you that within a time frame, okay, by how much distance the body is being transferred here. Okay, so you already know that distance covered in any particular time or any particular nth second here can be written as Sn is equal to u plus a by 2n minus 1. So this is the general relation of the distance covered during the nth second here. So now let us suppose at time equal to 1, at t equal to 1, the distance covered is going to be equal to. So now just see, the body is being starting from the rest here. So I can directly write the u is going to be 0. U is going to be 0 only. Okay, and the S1 is going to be equal to g by 2 because the body is falling under the gravity here, and the value of n is 1 here because we are taking the time as 1 second now during the first half. So I can write the distance covered will be equal to g by 2 here, and similarly at time equal to 2 second, the distance going to be covered as 3g by 2 here. Okay, and similarly I can write t equal to 3 second, g by 2. So if you just take the ratio of all of these distances, S1, S2, S3, you are going to see that it is following this particular ratio here, 1, 3, 5 and so on. Okay, so I can say that the ratio is coming out to be odd numbers here, 1, 3, 5, 7, 9, and starting with the unity here. So option number D is going to be the correct answer of this part here. Okay, now the next question. So now the next question is, an astronaut suddenly gets separated from a small spaceship. An astronaut, just see, astronaut is suddenly gets separated from a small spaceship if the spaceship is accelerating in the interstellar space at a constant rate of 60 meters per second. So let us say this is the spaceship here, this is the spaceship, and the astronaut has been separated from it. Okay, so now there are no nearby stars to exert the gravitational force on the astronaut. So as you already know that in this space every two bodies basically attract each other here. Okay, so now in that case we have to find out with which acceleration the astronaut is moving here. So can I say that if there are no star present nearby the astronaut and there is no force of gravity, there is no attraction force between these two between the stars and the astronaut, then there will be no force acting on the astronaut here. Okay, so in that case we can directly write, if the net force over the astronaut is going to be 0, that correspondingly means the acceleration is going to be 0 only. Okay, so that is why the option number C is going to be the correct answer in this case here. Now the next part. A car is moving with uniform motion here. Now the velocity time graph for the car will be. So now just see. Now we have to create the velocity time graph, not the position time graph. In the previous question we have drawn the position time graph here. So in this case, now you are creating the velocity time graph here. Okay, so you can see whenever the body is moving with a uniform motion, that simply means its velocity is not changing with respect to time here. Okay, so I can directly write the graph is going to be have a horizontal shape, or I can say it is going to be a parallel to the x-axis here, because due to the change in time, the corresponding velocity is not changing. It is moving with a uniform motion. That is why only. Okay, so therefore the option number D is going to be the correct answer. A straight line parallel to the x-axis here. Now the next part, question number 17. A particle is moving in a plane. Particle is moving in a plane and its position is given by r is equal to 5t square I cap plus 4t j cap, where t is in second and r is in meter, and you have to calculate the velocity of the particle at time t equal to 2 seconds here. Okay, so we have to find out the velocity. So position vector has been given to us, r is given to us, it is having a value of 5t square I cap plus 4t j cap here. And what do you want to find out? You want to find out the value of the velocity at time equal to 2 seconds. So I can directly write the velocity is going to be equal to 10t plus 4j here. Okay, so that will be the velocity vector. So now at time equal to 2 seconds, just put the value of the t in the final expression, and you are going to get 20 I cap plus 4 j cap. This is going to be the answer here. Okay, so I can write the option number B is going to be the correct answer in this case. Now the next part, oh sorry, yes, the next part is a biker comes to a sudden stop. Bikers come to a sudden stop in 50 meter. During this process, the force experienced by the bike due to the road is 200 Newton. The force acting on the body or on the bike is 200 Newton, and correspondingly it is covering a distance of 15 meter. It is covering a distance of 50 meter before coming to rest here. Okay, and what do we want to find out? We want to find out the value of the work done here. So can I say that the work done is nothing but it is a product of force into distance here. Okay, so in this case you can directly see the work done can simply be calculated by force multiplied by distance here. So this force which is being applied due to the road here is acting like a braking force here. So I can write the work done is going to be equal to 10,000 here. Okay, so option number B. So now just see one more thing. In this case, the option number C and option number B are having the same magnitude. The first one is the negative sign and here we have a positive sign. Okay, but in this case, the biker is coming to a sudden stop. During this process, the force experienced by the bike due to the road is 200 Newton. And you can see this force directly opposes the motion of the bike here. So I can say this work done has to be done in the opposite direction here. Okay, to stop the vehicle here. So I can say the option number B is going to be the correct answer here, that is minus 10,000 joule here. Now the next part, the action and reaction force in the third law. So that's a very simple question. Okay, this question doesn't require any explanation here. According to the Newton law, to every action there is an equal and opposite reaction here, and it always acts simultaneously here. Okay, so option number D is going to be the correct one. Now the next part, which of the following is a dimensionless quantity? So you can see, first of all, the surface tension is not a dimensionless quantity because it is a force which is acting per unit length here. Okay, moment of inertia is also not a dimensionless quantity because it is having a unit of meter to the power 4 if you are calculating the area moment of inertia. It is having a unit of kilogram meter square if you are calculating the mass moment of inertia here. Okay, so I can say the option number A, refractive index and the strain are going to be the correct answer here. Now the next part, if a particle moves in a straight line, okay, such that the distance traveled by it is given by s equal to 5t square plus 16t plus 9 here. What is the initial velocity of the particle? We have to find out the initial velocity here. So can I say that in this case, first of all, the velocity is given by rate of change of displacement. Okay, so if you just differentiate it, you are going to get this velocity. That is how the velocity is varying with respect to time here. And during the and in the question we have to find out the initial velocity. Initial velocity, that it simply means at time equal to 0 what is the velocity of the object. So that you can directly just put at time equal to 0, we can say the velocity is going to be equal to 10 multiplied by 0 plus 16 here. Okay, so velocity is going to be 16 unit per second here. Okay, so option number C is going to be the correct one here in this case. Now the next part, a ball is projected horizontally with a speed of 20 meter per second from a point 0 meter and 10 meter here in the xy plane. So let us say we have a xy plane here. Okay, so initial point are this one 0, 10 here, and the ball is projected with a speed of 20 meter per second in the horizontal direction. Now the ball strikes the ground at a point x meter into 0 meter. So I can say, let us say the ball is striking the ground at a distance of x, 0 here. Okay, now what will be the x here? We have to find out. This horizontal distance we have to find out here. Can I say that the ball is covering the x amount of horizontal distance and this 10 meter, or I can say this 10 meter of vertical distance in the same time here. Okay, so I can directly write y is going to be equal to vt plus half at square here. So now you can see the velocity the ball has been projected with the velocity in a horizontal direction only. So initial velocity is only along the horizontal direction. There is no velocity component in the downward direction. So that simply means now the y is equal to 10 here because it has covered the 10 meter of distance. Velocity is 0, time we don't know. Okay, acceleration is gravity, that is 10, and time we don't know. Okay, so if you just simplify it, you are going to get the time taken by the ball is under root of 2 second here. So that much amount of time has been taken for the ball to move from A to B here. Okay, now the next part is how much horizontal distance it has been covered. So now you can see x is equal to ut plus half at square. Okay, you can use this particular relation here. So in this case I can directly write, what is the formula now? Okay, so in this case we have been provided with the velocity. Okay, so now it is moving with the constant acceleration in the horizontal direction here. Okay, so in this case you don't have to take the second term. The second term will be 0, and correspondingly distance we have to calculate. Velocity with which it has been projected is 20 meter per second. The time it has been taken as under root of 2. So x is going to be equal to 20 root 2 here. Okay, so that will be the correct answer in this case here, even though the options are not matching, but the answer is coming out to be this one here. Okay, at 20 root 2 meter here. Now the next part is question number 23. A ball is projected from a origin in the xy plane here with velocity u, making an angle theta naught with the x-axis here. The ball has been projected with the velocity u at an angle of theta naught here. Now what will be the horizontal range of the ball? So that's a directly formula based question here. In this case the option number B, u square upon g multiplied by sine 2 theta is going to be the correct answer here. Okay, now the next part, which of the following is not an SI unit? So I have already told you that whenever you are defining the SI unit, there are 7 fundamental units. Along with that we have 2 supplementary units. Okay, and the remaining are the derived unit here. Okay, and when we talk about the fundamental unit, we have a mass, length, time, okay, luminous intensity, ampere, Kelvin, this type of SI unit we are going to have. So in this case the liter is not basically a SI unit here. Okay, now the next part, so yeah, there is no space now. Chalo, no problem. A point mass is having a velocity of v is equal to 1 I plus 3 j cap at the same instant it experiences a force of minus 2I plus 4J plus 5K. Okay, the power delivered by the force at that particular instant is given by. Okay, so now just see, we have to calculate with the power here, and a point mass is moving with the velocity in the xy plane, and it is experiencing a force which is given by this particular vector form here. Okay, so in that case, if you want to find out the value of the power, first of all you have to remember that power is nothing but a rate of doing work here. Okay, it can also be calculated by taking the product of force multiplied by velocity here. So you can see the force experienced by it is equal to 2I cap plus 4J cap plus 5K cap here. So this is the force. Along with that, the velocity is 1I plus 3J. Okay, this is the velocity here. So if you just take a simply dot product of it, you are going to get the value of the power here. So just take a dot product, you will get minus 2 plus 12 plus 0, and the power is going to be equal to 10 watt. This is going to be the power here. So option number C is going to be the correct answer here in this case. Okay, so that's a very simple part. Now the next part is dimension of the thermal conductivity we have to check. So in this case, the dimension of the thermal conductivity, see, thermal conductivity is defined with the help of Fourier law of heat conduction. Okay, and it tells you about the ability of the heat to pass through the solid body here. And the Fourier law is given by minus K8 dt by dx here. So you can see the dimensional unit, the dimensions of the thermal conductivity can be calculated by taking the ratio of Q by dt by dx here. Now while calculating the heat transfer, we always calculate the heat transfer in the watt here. Okay, and what is the meaning of watt? Watt is basically a unit of power, and power is defined as the force into velocity. So I can directly write force, which is a product of mass into acceleration multiplied by the velocity here. So you can see the watt is having a dimensions of ml2 t minus 3 here. Okay, this is the unit dimensions of the watt here. So just put all the expression here, ml2 t minus 3, A is given to you L square dt. dt is the temperature difference, so I can write Kelvin here. dx is the thickness, which can also be written as L here. Okay, so if you just simplify it, you will get the unit as ml t minus 3 k minus 1. So this is going to be the units of the, or I can say the dimensions of the thermal conductivity here. Okay, so I can say the option number B is going to be the correct answer here in this case here. Okay, now the next part, question number 27. The position time graph of a ball which is moving in a straight line inclined at an angle of 30 degree to the x-axis. Okay, so we have been provided with the information that the position time graph of an ball which is being moving in a straight line. So ball is moving, okay, and the corresponding displacement variation with respect to time is given by this particular line here. Now the ball is moving with increasing acceleration, increasing velocity, constant velocity, decreasing acceleration here. So here you can see the displacement, or I can say displaced position time is graph is straight line. Okay, that simply means the velocity, the body is moving with the constant velocity. The velocity is not changing here. Because if the velocity is not changing, that simply means it is covering the same amount of distance in the same interval of time here. Okay, so I can say it is not, it is moving with zero acceleration, or I can say with constant velocity here. So option number C is going to be the correct one here. Now the next part, Mohan of mass 60 kg run up a flight of stairs having a rise of 5 meter in 6 seconds. The average power supplied by him during the run up here. So Mohan is a person which is moving in the upward direction on the stairs here, and it is covering a 5 meter rise. 5 meter rise it is covering in 6 seconds here. Okay, now we have to calculate the average power supplied by him during the run up. So can I say that the power is nothing but the rate of doing work? Okay. And in this case, when the Mohan is moving from number 1 point to number 2, the work which is being done by him, it is given by force into distance, or I can say the potential energy, mgh here, and divided by time, it will provide you the value of the power itself. Okay, so that's a very simple question. So in this case, the mass is given to you as 60, gravity is 10, height is 5 meter, and time is 6 seconds. So I can say the power will come out to be as 500 watt here. So that means option number C, 0.5 kilowatt will be the correct answer in this case here. Okay, so again this question is a very simple case. Any doubt here in this case? Now we are only left with some few questions here. Okay, so let us start with the next part here now. Now the next part is 28, yes 29 here. So 29 question is a physical quantity which is given by x equal to a square b cube c to the power minus 1 by 2 d to the power 1 by 2. If the percentage error involved in the measurement of a, b, c are given to us, then what will be the percentage error in the result x will be? So that's a very simple question. So I have already told you that whenever this type of question is being asked, the simple error which is being induced in the final calculation can be calculated by, we are having the a square, that can be written as 2 delta a by a. B is having a power of 3, so we can write 3 delta b by b plus 1 by 2 delta c by c plus 1 by 2 delta d by d. Okay, now we know that the error which are there while calculating the value of a is 1%, while calculating the value of the b will 3%, and the error induced in the C term is around 4%, and in the D terms we are having again the error of 2% here. So if you just simplify it, you are going to get the final answer here. Okay, so you can see just do the sum here and you will get your final answer as 14% here. 2 plus 9 plus 2 plus 1 here. Okay, the answer will come out to be as 14%. Now the next part is yes. Now a ball is thrown upward at a place where the acceleration due to the gravity is 9 meter per second. Now acceleration of the ball during its motion upward and its highest point respectively are. So now just see, now the ball has been thrown in the upward direction. So now can I say that whenever the ball is moving in the upward direction, the ball is going to experience the acceleration equal to gravity itself only, but in the opposite direction, because it is moving in the upward direction and the gravity is acting in the downward direction. So I can say during this upward motion, the acceleration which is going to be experienced by the body is only minus 9.8 meter per second here. Okay, so now as soon as it reaches the highest position, its acceleration is going to be remain in the same direction here. Okay, at the highest position. Now after reaching the highest position, now what will happen, its velocity will become equal to 0. Okay, due to the negative acceleration only, its velocity is continuously reducing, and at the highest point its velocity is going to be 0. After attaining the highest point, it is going to move in the downward direction, and then again its acceleration is going to be maintained at the value of the plus 9.8 here. So I can directly write the acceleration during its upward motion here, and when it is about to reach at its highest point, the acceleration is going to remain same, that is equal to minus 9.8 meter per second. But whenever it is moving in the downward direction, at that point the acceleration is going to be equal to plus 9.8 meter per second. So I can directly write the option number C, minus 9.8, and 9.8 is going to be the correct answer here in this case. Okay. Now the next part is a point is moving with a velocity of 10 meter per second, and at a subsequent instant it is moving at a same rate in the direction inclined at 30 degree to the former direction. Find the change of velocity. So what is happening now? In this case, a point is initially moving with a velocity of 10 meter per second here, Now after an instant of time, now it is moving with the same velocity only, but in the different direction. Now the direction has been inclined by the 30 degree. So that simply means initially the body is moving in the horizontal direction, then after that the body is changing its direction, velocity direction here, and it is moving in the 30 degree. Okay, now we have to find out the value of the change in velocity here. So now in this case, just see, if I just ask you that what will be the initial velocity vector, what will be the initial velocity vector? So can I say that initially, let us assume the body is moving in the horizontal direction. So velocity vector will be given as 10 I plus 0 j cap. This is going to be the initial velocity vector. Now what is happening? Now the body is changing its direction here. Okay, now the body is moving with the direction at 30 degree oriented here. So I can say if the body is moving in the inclined direction, which is making an angle of 30 degree, in that case the velocity is going to have a two component, that is one 10 cos of 30 along the horizontal direction and 10 sin of 30 along the vertical direction. So I can write the velocity vector will be written as 10 cos 30 I cap plus 10 sin 30 j cap here. So it will come out to be as 5 root 3 I cap plus 5 j cap here. Now what is being asked to calculate? We have been asked to calculate the change of velocity. What will be the change of velocity? You can write the change in velocity will be equal to the difference, that is 5 root 3 minus 10 I cap, that is the change in velocity. Initially we have a 10 and then we have a 5 root 3. Now change in velocity will be the difference here. Along with that we have a 5 minus 0 j cap here. Okay, so if you just take the difference here, the answer is coming out to be around, now the answer is coming out to be around minus 1.34. Just do the calculation here and you will get this final velocity vector. You are going to see this change in velocity vector here. Okay, and if you just calculate the final magnitude of the velocity, final magnitude, in that case you can simply do the calculations here. It will come out to be as minus 1.34 square plus 5 square, and the answer will come out to be as 5.176 meter per second here. Okay, so option number A is going to be the correct answer in this case here. So that's again a very simple part here. Now the next part, yes, now in this question what is given to us? A cage in a mine shaft descend with 2 feet per second unit of acceleration. So now you can see a cage is moving in the downward direction with the acceleration of 2 feet per second. After it has been in motion for 10 seconds, a particle is dropped on it from the top of the shaft here. So first of all, what is happening? A cage has been descending in the downward direction with the acceleration of 2 feet per second. Okay, so now it has been descending for the 10 second here. After descending for 10 seconds, what we have done? We have dropped a particle from the top of it. Okay, now at what time the particle hits the cage here? Okay, so that simply means, so this question is little bit a complicated question here, because in this case the statement is little bit confusing here. So we have been provided with the cage which is descending on a mine shaft here. Okay, and now it is moving with the acceleration of 2 feet per second, and it has been moving for 10 seconds here. So after moving for 10 seconds, a particle is being dropped from it. Okay, so I can say the particle is covering a different distance and the cage is moving with a different acceleration here, so it is covering a different distance. Okay, because you can see the cage is moving with a different acceleration of 2 feet per second and the particle is being dropped and it is moving with the acceleration of gravity, acceleration due to gravity here. Okay, and in the feet form, in the FPS system, I can directly write the gravity is going to be equal to 32 feet per second square here. Okay, so in this case, the first of all the gravity value is going to be equal to 32 feet per second here. Now what times elapse before the particle hits the cage? Okay, so we have to equate the distance covered by the particle and we have to equate the distance covered by the cage here. So let us start with the calculation part here. Just wait a minute. Yeah. So now just see, first of all, in this case what we have to calculate, first of all we have to understand the laws of motion. So there are three equations which we have to use here in this case. The first equation is V is equal to U plus AT. The second equation is S is equal to UT plus half AT square. And the third equation is V square is equal to U square plus 2A square. Okay, these three equations we are going to use in this equation, and most probably the second number equation is going to be used here. Okay, so first of all just calculate how much distance is being covered by the cage here. So first of all just see, the distance covered by the cage can be calculated by the formula of UT plus half AT square here. Okay, so now in this case, in this question, it is being asked the cage is descending with the acceleration of 2 feet per second and it is descending for 10 seconds here. So let us say the initial velocity is 0 here and time is 10 seconds. For 10 seconds it is being descending here, plus half acceleration is given to us 2, distance this time is 10 here. So I can write the cage has covered the distance of 100 feet here. Okay, so that simply means during the 10 second of motion the cage has covered a distance of 100 feet here. Okay, the first thing we have calculated here. Now what is happening? Now after covering the 100 feet here, the particle has been dropped from the cage here and the particle is now moving. Moving under the influence of this acceleration due to gravity here. Okay, so now you can see after the 100 feet the cage is moving with a different acceleration, particle is moving with a different acceleration, and we have to calculate the time when it will meet. Okay, so we can simply calculate the time by equating the distance covered by these two bodies here, because of the at what time they have covered the same distance, we will get our final answer. So now I can say the distance covered by the particle. Now that we have going to see the distance covered by the particle. So can I say that the same equation I can use? So now just see, the P subscript is representing the particle here. So particle is dropped from the initial velocity 0 here. So I can say the first term is going to be 0 and acceleration is gravity here and the time we don't know. Time we don't know here. Okay, or I can further write it as half 32 t square. Okay, so this is the equation number 1. Similarly, I can write it for the cage also. Okay, I can write it for cage also, and in the case cage, now the cage has already covered a distance of 100 feet. Okay, just wait a minute. In this question, at the cage, na? Yeah. So now in this case, the cage has already covered a distance of 100 meter here. Okay, so this is the 100 feet. Along with that, plus it is descending with the velocity with an acceleration of 2, and we don't know the time here. So this is going to be the equation number 2 here. So now in this case, when you want the particle to hit the cage here, the distance these two covered which should be the same here. Okay, so I can directly write half 32 t square is going to be equal to 100 plus it will be cancel out t square. So you can see it is coming out to be 15 t square equal to 100, or I can further write it as 20 divided by root 3, sorry 20 by 3 here under root, and this will be the answer we are going to see here in this case. So I can say the answer will come out to be as 1/3 second here. Okay, so I can say the option number B is going to be the correct answer, 1/3 second here. Okay, so that's our question here. Now the next part is, which of the following quantity is a vector quantity? So out of this you can see the torque is the only quantity which is can be considered as a vector, because it is having a magnitude as well as the direction also. Now the next part, a subway train starts from rest at a station and accelerate at a rate of 3 meter per second square for the 10 seconds. So first of all, the subway train is starting from a rest and it is accelerating at a rate of 3 meters per second for the 10 second, and then after 10 second it is running at a constant speed for 20 second, and then after that it is deaccelerating at a speed with the retardation of 5 meter per second square here. Now what will be the total distance covered between the two stations? So can I say that there are three distances we have to cover. In the first distance the body is accelerating, in the second distance the body is moving with a constant speed, and in the third distance the body is moving with the retardation here. Okay, so in this case, so let us start with the calculation one by one here. So in this case I can write S1. S1 is the distance covered by a body when it is accelerating here. Okay, so in that case you can directly write ut plus half at square. So you can see the train has been started from the rest. So first term will be 0 and acceleration is given to you 3 and it is moving for 10 seconds here. So I can write the distance covered by it is equal to 150 meter here. Now what is happening? Now after 10 seconds it is moving with a constant speed for 20 seconds. So now let us calculate what is the speed after 10 seconds here. Okay, so can I say that so it has been moving with the 3 meter per second square here. Okay, so now let us calculate the speed at the end of the 10 second here. So speed is going to be equal to u plus at. So you can see the u is 0, acceleration is 3 and t is 30 meter per second. So after 10 seconds the train is having a speed of 30 meter per second and it is moving with this particular constant speed for 20 seconds. So I can directly write the S2 is going to be equal to V1 into T2, 30 into 20, that is 600 meter. So at constant speed it has covered a distance of 600 meter now. Now what is happening? Now it is deaccelerating at 5 meter per second until it stops at the next station here. Okay, so now in this case the third distance, so you can calculate the third distance. So I can use the third law of motion here, v square equal to v1 square plus 2as. So now you can see at the end of 20 second, at the end of 30 second, initial 10 second and after 20 second, the speed is 30 meter per second. Okay, the v1 is 30 meter per second. Now what is happening? It is deaccelerating with the acceleration of 5 meter per second. Okay, at a rate of 5 meter per second here. Okay, it is deaccelerating with the acceleration of 5 meter per second here, and the final velocity is 0. So I can directly write v2 square is going to be 0, v1 square is given to you 30 square, and acceleration is given to you -5, and S3 we have to calculate here. So I can directly write the S3 will be 900 divided by 10 here, and the answer will come out to be as 90 meter. So therefore the total distance which is covered by the train as S1 plus S2 plus S3, it will be equal to 150 plus 600 plus 90, and the answer will come out to be as 840 meter here. Okay, so that means the option number A is going to be the correct answer in this case. Now the next part, 35. The escape velocity for a body of mass 1 kg from the earth's surface is 11.2 meter per second here. 11.2 kilometer per second here. The escape velocity of a body of mass 100 kg would be. So first of all, just see what is the escape velocity. Escape velocity is the velocity with which the body has been thrown in the upward direction so that it escape out the gravity of the earth here. Okay, and the formula of the escape velocity is given by under root of 3gm divided by r here. So in this equation, g is the gravitational constant. G is the gravitational constant here, and capital M is representing the mass of the earth here, and r is representing the radius of the earth here. Okay, so you can see the escape velocity is not depending upon the mass of the object. So no matter whether the mass is 1 kg or mass is 100 kg, the escape velocity is not going to be changed. So therefore I can say the option number C, that is 11.2 kilometer per second, is going to be the correct answer in this case. Okay. Now the next part, two springs are connected to a block of mass m placed on a frictionless surface as shown below. If both the springs are having a spring constant k, the frequency of the oscillation of the block. The very simple question is there. You have to calculate the value of the frequency of the oscillation. Okay. Now what is the meaning of frequency of oscillation? So first of all, you have to calculate the time period here. Okay, so just first of all, just calculate the natural frequency. So in this case, if you see the diagram very carefully, the two springs are attached in the parallel configuration. So whenever the two springs are attached in the parallel configuration, the equivalent stiffness can simply be calculated by the sum of these two stiffnesses here. Okay, so I can write K equivalent is going to be equal to 2K here. So this is going to be the equivalent stiffness. So I can directly write the formula of the natural frequency. The natural frequency is going to be equal to under root of K by M. So natural frequency will become equal to 2K by M here in this case. Okay, 2K by M will be the formula. Now in this case, we know that frequency is natural frequency is equal to omega n by 2 pi. So I can directly write 1 by 2 pi under root of 2K by M is going to be the correct answer in this case. So option number C is going to be the answer of this particular question here. So that's again a very simple question. Now the next question. So if a coordinate system is attached to a rigid body and one describe the position of a particle, coordinate system is attached to a rigid body here and one describe the position of any particle relative to it, then such coordinate system is called. Okay, so basically in this case the coordinate system has been attached to the fixed body here, so we can say it can be considered as a frame of reference here. Okay, from where you are calculating all the distances here. So option number A is the correct one here in this case. Now the next part, so it is the last question hour. If a small displacement of a system from the rest position after getting some energy is result in a small bounded motion after the about the equilibrium position, then the system is going to be known as neutral, unstable, natural or stable equilibrium. Now what is being asked here? A small displacement of a system from the rest position results in a small bounded motion about the equilibrium position here, then the system is going to be known as stable equilibrium. You can understand in this way. Let us suppose if you have a surface like this one and we have a ball like this one here. Now what you have done, this ball is initially at the rest position here and you have just displaced this body from position number 1 to 2. Now if you just leave it, this body, what will happen? The body will move, the body will take this particular motion here, okay, and it is continuously going to bound about its mean equilibrium position here. So in that case the body is in nothing but it is in the stable equilibrium only. Okay, so the option number C is going to be the correct answer in this case. So these are the questions which are being asked from the +1 physics here, okay, in the ATC exam in the last years, okay, when the exam has been taken place. So you can see all the questions which we have covered, me and Rajiv sir. The questions are very simple. Okay, if you just know the basic approach, if you have a right approach to solve the problem, you can solve it within a very short period of time here. Okay, so just make ensure that whenever you are preparing for the physics, whenever you are preparing for anything in this for this particular exam, just try to understand it in a very simple manner here. Okay, then you will easily solve each and every question in this case. Okay, so thank you very much.